We're doing 1.2 relations and functions. There are 4 ways to represent a relation. So we have the graph. Remember, this is the x-axis, this is the y-axis. We have ordered pairs, x comma y. Then we have a table of values, and then we also have a mapping. So let's take this table of values and make it into a mapping. So the x values, you want to go ahead and put them in order from least to greatest. And then you also want to put your y values in order from least to greatest. So it looks like, so then for the y values, we would start with the smallest. So -5, -2, and that actually covers both of them. You don't have to list them twice. 0, 1, 2, and 6. And they don't have to match up, because what you're going to do, if you remember, is put arrows, and you're mapping an x value to a y value. So let's start with our first one, -5, 1. -5, 1. -3, -2. -2, -5. 0, 0. 2, 2. 4, 6. And 5, all the way up to -2. Okay? So we have matched them all. So let's go ahead and talk about the next topic, which is domain and range. So domain, if you remember, is the set of all x values. Oh, it's all right here. Domain is the set of all x values so those are your input values. And range is the set of all y values, which is our output values in the relation. So I'm going to erase that. So let's go ahead and find what the domain is of this relation, which, if you noticed, these are all the same. It's the same relation represented 4 different ways. So the domain is a set of all x values. So we do it with interval notation, set builder notation, which is these little squiggly braces. So we're going to start with smallest number. So -5, -3, -2, 0, 2, 4, and 5. And then our range is our y values, listed in order from least to greatest. So to know if it's a function or not, remember every x value has to have exactly one y value. So if you look at it, do x's repeat? And they don't, so it is a function. X values don't repeat. Okay, so now let's talk about a function. The actual definition is a function is a relation that has only one input, and that's our x, for every output. In other words, no repeated x values. That's how you know. And do y'all remember the vertical line test? The vertical line test is how to check if a graph is a function. Okay, so let's go ahead and move on, because that is on the next page. We have this example, list the domain, range, and determine if the relation is a function. So let's go through. Our x values are 1, -2, 1, -4, and 2. So let's start off with our smallest x. So let's start with -4, -2. So -4, -2, and then 1 and 2. And then our y values, 9, 5, 6, 3, 8. So 3, 5, 6, 8, and 9. And then we draw the arrows. So we have 1 is with 9, -2 is with 5, 1 is with 6, -4 is with 3, 2 is with 8. Okay, so see how we have this x, the value 1, it actually goes to 2 different places. That means it is not a function. So if we list, so for both of these, it's going to be the same domain and range. So we're kind of combining number 1 and number 2 together in this one. So domain is, I'm going to put D, is -4, -2, 1, and 2. And then our range, 3, 5, 6, 8, and 9. And we already determined it's not a function. So these two actually went together. So we're going to work that out. Okay, number 3. So if we look at our graph, we need to write our domain and range. So that means we need to write our ordered pairs. Or we can just look at what the x values are first. So if I look at this, I can go, what is the smallest x value? -1, -2, -3. So I'm going to start there. And then -2, and then this one is 0, this one is 2, this one is 3, and this one is, let's see, 1, 2, 3, actually that is 4, because that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then our range is the y values. So I'm going to start at the lowest and this, see where it would be on the y. -1, -2, -3, -4, -5, -6. And then up to -5. Then 0, 2, 4, and 5. And looks like that's 6, right? See, 1, 2, 3, 4, 5, 6. That's actually 7. Okay. So if we look at them, do any of the x values repeat? See how this one was twice? That it's at 1, 2, 3, 4. 4 would have been listed twice, so this is not a function either. Okay, now we'll go to the vertical line test. I kind of gave you a preview right here. So the vertical line test, the VLT, states that if a vertical line passes through more than one point on the graph of relation, then the relation is not a function. Use the vertical line test to determine whether each graph represents a function. So if I were to draw vertical lines, each vertical line only passes once. So this is a function. Next one, if I draw a line, See how this line passes through twice? So automatically this is not a function. And the next one, even though this is a funky graph, it is still a function. Okay, we are going to find domain and range of continuous graphs. So continue means that it continues on and on forever between 2 points. So there's an infinite number of points between the 2 points. If you just had dots, that would be discrete and not continuous. So we are going to use both set builder and interval notation to describe the shaded region. So I need to give you the shaded region. I'm going to put an open circle on -3 and go left on that one. So, and then I'm going to go ahead and do the domain and range. So domain is the set of all x values with a line that means such that, and then I describe this. So the way I would describe this is it's at -3 or less. So its x is less than -3 because that's an open circle. This goes on and on to -infinity. So x is less than -3. Another way you can tell how to write your inequality is see how this inequality symbol and this arrow match. They're both pointing to the left. That's one way. All right, so that's domain. And then this is called set builder notation. And so we're also going to do interval notation. So interval notation is with either brackets or parentheses describing what these values are. So it goes from -infinity to -3. Anytime you have infinity, it's always a parenthesis. And if it's an open circle, it's a parenthesis. You would use brackets if this was closed. Okay, let's go to the next one. So what I'm going to give you is a closed circle on -3 and an open circle on 4. And shade everything between. So domain is a set of x values such that, so now we got to describe this. So it goes from -3 to 4. And this is a closed circle. This is an open circle. So it's -3 is less than or equal to x is less than 4. So this is an open circle. So it's just less than. This is a closed circle. So it's less than or equal to. And then the interval notation are these two numbers, -3, 4. And this is closed, so it's a bracket. And this is parenthesis because it's open. Okay, and then the last example for this is we have a closed circle on -1 and an arrow. So let's fill in this. So this is at -1 and it goes to infinity. So that's how you would describe it. And that's going to help us with our interval notation. So let's say domain is the set of all x such that it goes from -1 to infinity. Or we could say x is greater than or equal to -1. And you can also see these match. And then our interval notation, we're going to use these two numbers. So -1 comma infinity. This is a bracket. And this is a parenthesis. Parenthesis is always with infinity. Bracket is always with closed circles. All right, now we're going to do this domain and range, but with a coordinate grid. So let's look at domain. So domain is x. So it looks like it goes from, that's an open circle, -1, -2. So it goes left, -2, and right, 1, 2, 3. So left and right is your domain. So our domain for set builder, this doesn't give me much room, but we can still do it. X such that it goes from -2 to +3. And these are both can be less than, except this is a closed circle, so this is going to be less than or equal to. Close your set builder. And then interval, you're going to use the two numbers, -2, 3. This is a bracket on 3. This is a parentheses on the -2. Okay, let's go to range. I'm going to do a different color. Range is low to high, or how far down to how far up for range, because this is your y-axis, right? Your y-axis goes down and up. Your x-axis goes left and right. So whenever we do range, let's see, it goes down to 1, 2, 3, 4, 5, -5. And it goes up to 1, 2, 3, 4, 5 to +5. So range, don't forget to change this value to be y, such that it's in between -5 and +5. This is open circle, so it's less than. This is closed circle, so it's less than, equal to. And then to do the interval notation, we're going from -5 to +5. Open circle is parenthesis. Closed circle is bracket. Okay, let's go to the next one. Domain. So our x values go from left to right. Left, it looks like goes 1, 2, 3, 4, -4. Right, there's an arrow, so that means infinity. So it's the x values such that x is at -4 or larger. So x is greater than or equal to -4. So our interval notation would be -4 to infinity. We use brackets on the numbers that have closed circle, parenthesis on infinity. Now let's do our range. It's how far down to how far up. So it goes down to 0. Goes up, it's here, but then that has that arrow, so that means infinity. So it's the y values such that y is at 0 or greater, so greater than or equal to 0. So it doesn't have a closed circle, but it doesn't have an open circle either. So that we assume that it actually touches the 0 on the y-axis. So this would be from 0 to infinity, parenthesis on infinity, because it touches, it is a bracket. Okay, let's go to the next one. We have domain is left and right. Left, it goes to -1, but that arrow means it goes on and on forever. So it's going to the left forever, so that's -infinity. And then the right, 1, 2, 3, 4, it stops at 4. So it is x such that x is at 4 or less. So x is less than or equal to 4. Kind of like this number 1 up here with our number line. It's at -3 and it went left. This one was at 4 and it went left. So that's why we get x is less than or equal to 4. And so our interval notation, you always start at the left. So -infinity to 4. Closed circle, so that's a bracket. Parenthesis. Okay, range, low to high, or how far down to up. I do down to up because that doesn't make it so confusing. All right, This is an arrow going down, 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 which means negative infinity. And it goes up to 1, 2, 3, 4. The maximum is 4. So this is at y such that y is at 4 or less. So less than or equal to 4. And so our range is going to be from negative infinity to positive 4, which actually looks the same even though they are different. They will not always be the same. Just like these other ones, they weren't always the same. Okay, let's keep on rolling. We have 2 more. We're going to come back to these. To find the domain of a function, we need to find out what value is going to make the function not a real number. So you only look at x because it just says finding the domain. So we're only looking at x. So what I'm going to do is, this is just a regular quadratic. We know that because of the squared. So if we were to graph this, we would see that it's a regular quadratic. There should be no restrictions on this, and nothing will make this not true. So I'm going to put it into the calculator just so you see it as a reminder. Okay, so it is just a regular quadratic, like this somehow. So if we're talking about x values, it goes from negative infinity left to positive infinity right. It's going to go on and on forever. So our domain, I'm going to do these as interval notation, negative infinity to positive infinity. All right, the next one, this is a square root function. So if I put that in, I just want to show it to you. So it looks like this. So it starts at that value, which is 4, and it goes to negative infinity. So that is going to be our domain. But what I want you to see is we want to know what would make this not a real number. You can't take a square root of a negative number. It doesn't exist. It's going to be imaginary. So what we are going to do is we are going to set this equal to 0 so we know what will be the last number that it could possibly be without going to imaginary. So if you have square root, the opposite would be to square it. So we have 4 minus x equals 0. Then we would solve, well, what's 4 minus to get to 0? Well, it's 4. But if we were to show this, you'll see it like this. Drop a negative 1. So x equals positive 4. So x cannot equal positive 4. So this is where the function will stop. And we know it's going to the negative side, negative infinity, because if I put in any number that is smaller than 4, it'll be fine. If I put in a bigger number, let's say 10, that gives me a negative 6, and I can't have that. So my interval notation for domain is this. And it includes 4, because 4 is fine, because it'll give me 0. So it cannot be anything smaller than 4.
Teachers, at this time, someone will be coming.
Okay, the next one, for this function, what causes a fraction to be imaginary or won't exist? This would be if this equals 0. So 4x minus 1 cannot equal 0. That's what that's telling me. That one couldn't equal 0 either. So if you have a 0 on the bottom, remember when we were talking about slope, if we have 0 in the denominator, it's undefined. So we don't want an undefined part of a graph. So that's going to be a domain restriction. So x cannot equal 1/4. This is where you're going to actually have a hole in the graph. So if you look at it, I'll show you what it looks like. X squared over 4x minus 1. So there, that is where the hole is. There's nothing there. We have some asymptotes going on. And if we were to look at the table, well, we can't see it because we're talking about the x value being 1/4. So what this looks like in the graph is if we just look at the domain and say that this is like 0 and this is 1, so this would be 1/4. So we have a hole at that location at 1/4, but it's going to go in both directions, left and right, to infinity. So the way we would write that is negative infinity, 1/4, then 1/4 to positive infinity. Okay, the last section is your function notation. So f of x is the same thing as saying y equals. If we have f of x and we have a value for x, then we are going to substitute in that value. So if we're saying f of negative 3, we're going to use the f of x function. So f of negative 3 equals negative 3 squared plus 4 times negative 3. When you sub it in, make sure you put it in parentheses. We can put this straight in the calculator. We can work it out by hand. Negative 3 squared is 9. 4 times a negative 3 is a negative 12. 9 minus 12 is negative 3. So we can say f of negative 3 equals negative 3. Now we use the g function, g of negative 5. So here's our g function. 5 minus 3 times a negative 5. 5. And then negative 3 times a negative 5 is a positive 15. When you add those together, you get 20. So g of negative 5 equals 20. Okay, now we have a fraction that we're plugging in for x. So g of negative 2/3 equals 5 minus 3 times a negative 2/3. So we get 5. Well, when you multiply straight across, you can actually cross cancel. So those are both 1s. Negative 1 times a negative 2 is a positive 2. Add those together and you get 7. And you can substitute it in using the calculator if you want. All right, that is it.